Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, uAbuti Sauce Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 12. It says A and B are independent events. Note that, independent events. It is further given that the probability of A and B, the intersection between the two events, is 0.3, and the probability of only B is 0.2. Now, 12.1.1 says, are A and B mutually exclusive? Motivate your answer. So we know that one. It's a big fat no. Why? Because the probability of A and B is not equal to 0, right? And then let's go to 12.1.2. It says determine the probability of only A. So for that one, just gonna start by representing my two events on a Venn diagram. So probability of A and then probability of B. So A, B events, and then we have the intersection is 0.3, but then it's been indicated that probability of only B is 0.2. So what we are looking for here is only A, right? But then we are told that A and B are independent events, so we can just go probability of A and B is equals to probability of A multiplied by probability of B. So this is the formula for independent events. Then obviously we have our 0.3 here, and then we don't have the probability of A. So probability of A is all of this, and then multiplied by the probability of B is all of that, which is 0.5. So it was very crucial that we indicate in our Venn diagram, because you might just have ended up multiplying with 0.2. So now when you represent in a Venn diagram, you can see that it is actually 0.5. Then divide both sides by 0.5. The probability of A is 0.6. But then remember, we are looking for the probability of only A. So only A is represented by the X here, which we can all agree that we can get that one by simply saying 0.6 minus 0.3. So the probability of only A is to take the whole of A minus the intersection between A and B. Then we have 0.3. So let's now replace the X there with 0.3. So voila. Then obviously to indicate all of this, we understand that the probabilities will have to add up to 1, right? So if you have decimals, all the probabilities in the sample space will have to add up to 1. So that means the probability of neither A or B occurring would have to be 0.3 plus 0.3 plus 0.2, then subtract that from 1. So complementary events. So we're going to get 0.2. So when you add everything up in here, it should give you 1, right? So always keep that in mind. And then let's now look for the B. Let's calculate B. So it says probability of not A or not B. Guys, this is different from saying the probability of not A or B, right? This is different. The probability of not A or B would have to be represented by the 0.2, of course. But then the probability of not A or not B is a different case. This means this one involves us having to find the probability of not A and also find the probability of not B. You understand that? So now, let's see how you tackle that one. So in solving B, we break it down to probability of not A and probability of not B. If we have to focus on probability of not A, that means we have to shade off A. So not A, that means we don't want A. So let's be on the mission of shading off A. So anything to do with A, we don't want. Right, so that means this leaves us with what? It leaves us with 0.2 and this 0.2. So let's indicate we have 0.2 and this 0.2. Right. Then if we are to check probability of not B, so probability of not B, so that means again, we have to assume that we haven't done anything, and then still have this one here. So still have our 0.3 back, and then also our 0.3. So not B means that this time around, we are looking to shade off B. So if we shade off B, anything to do with B, even that intersection is part of B. So that means we are left with 0.2 and 0.3. So 0.2 and 0.3. But then in both of these cases, we can say that we've been repeating one number twice. So in order to eliminate redundancy, we have to only put one of this number here. So the 0.2 here that we've been taking from here, right? So we only have to choose to put one number because we are avoiding repeating the same value. So that means the probability of not A or not B will now have to be represented by 0.2 and then this 0.2 and then 0.3. And when you add all that up, you get 0.7. So that is the probability of not A or not B, right? So I hope it makes sense. It's different from not A or B. So that was the confusion that a lot of you had regarding this question. Okay, so now let's go to 12.2. So we are now starting with our counting principles. It says a teacher has 5 different poetry books, 4 different dramas, and 3 different novels. She must arrange these 12 books from left to right on a shelf. Then 12.2.1 says write down the probability that a novel will be the first book placed on the shelf. The novel will be the first book placed on the shelf. So how many novels do we have? 3 different novels. And then how many books do we have in total? It's 12. So we know that the probability will simply just be probability of having a novel is 3 out of 12, which can be simplified further to 1 over 4. So that's all we needed to do there. As simple as that. So 1 mark. Then 12.2.2. It says calculate the number of different ways these 12 books can be placed on the shelf if any book can be placed in any position. So that means randomly, right? So whenever there is no restriction, we are just placing the books randomly. You just simply take the number of books and then a factorial. So that's 12 factorial ways. But because it's 12, it's 2 marks meant to say, that means you have to write that number in full. So that's 479 million and 1,600, right? Okay. So for 12.2.3, it says calculate the probability, the probability that a poetry book is placed in the first position. The 3 novels are placed next to each other and a drama is placed in the last position. So, okay, let's try to do what they are telling us there. Right. So in the first position here, we must have a what? A poetry book. So we have 5 different poetry books. That means we can have 5 options when it comes to the first position. In the last position, we must have a drama book. How many drama books do we have? 4 different drama books. So that means we have 4 options when it comes to the drama books. Now, obviously, if we have placed a book here and a book there, how many books are we now left with? It's 10, right? But then there is a restriction. The novels must always follow each other. So it's novel, novel, novel. Now we already know that these novels can be arranged in any different order, which is 3 factorial. Because again, if we have to break it down, can be novel 1, novel 2, novel 3, or it can be novel 1, novel 3, novel 2, or it can be novel 2, novel 1, novel 3, and then novel 2, novel 3, novel 1. Or it can be novel 3, novel 1, novel 2, or novel 3, novel 2, novel 1. So all in all, we have 6 different possibilities, which can be all summed up as 3 factorial ways. So it's very important to note that. Now, obviously, when we have placed these 3 books following each other, then that means the 7 remaining books can be placed randomly. So these are the 7 other books that can be placed randomly. So 7 other books. But then what is it that we know? Every time we are being told that the books or whatever items must follow each other, then we simply just take them as one item. Right? So this is one item. We want to assume that the 3 books are just one book, one item. So that means, in other words, after placing the poetry book in the first position and the drama book in the last position, we have 8 spaces to fill. Right? We have 8 because we have taken this one as one book, and then together with the 7 other books, that makes it 8. So that means now, in order to find the number of different ways in which we can place this is what we can do now. So it's 1, 2, 3, 4. Right. So the first position must be occupied by a poetry book. The last position must be occupied by a drama book. But then remember, in terms of placing the other books now, the 7 and the 1 item here, we can place them in 8 factorial ways. Because now, remember, we said we have 8 books. Right. So 8 factorial ways. But then remember, always when you take that 1 item, when you take that those number of books as 1 item, you must also consider that those items can be arranged in different ways, right? So how many different ways can they be arranged? In 3 factorial ways, which is 6 ways. We're having to break it down here. So that means these are the number of different ways in which you can place that. The 5 for the fact that you have 5 options in placing the poetry books in the first position. The 4 for the fact that you have 4 different options for placing a drama book in the last position. And then here you have 8 factorial ways in which you can place all the other books here. But then also consider the fact that you made this one a item. There's 3 books, 1 item. So that means they can be arranged in 3 factorial ways. So, okay, but then we are looking for the probability. So probability, we know that we're just going to take this one here, the number of different ways in which that can be possible, over the total sample space, which is without any restriction, the one that we just got in 12.2.2. Then the probability of that event occurring, you simply just need to punch your Mshinwe and then you get 1 over 99. Right. So I hope all of this makes sense, guys. And then you are able to just understand the concept of grouping as we are doing this past exam papers. So just make sure you stay in tune. I will still keep on posting more of these questions so that you get to understand them better. But then with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.